Hi, welcome to my channel. So in the previous video uh, we have built an image of our app using a Docker file, and then we created a repository in Elastic Container Registry service, and then we pushed the image using AWS command line. So the main purpose of this demo series is to show the use of application load balancer. So we want our application load balancer to distribute traffic among the containers, and to see this in action visibly, we want to display the IP of the container. But I'm sorry, I did one mistake again, and I finally found out a logic that can retrieve, that can get the IP of the container. So I have updated my code. Let me show you this one. So this is the updated code. All I need to use is this, and I found this the command from the AWS command documentation. So this will work. Okay, so okay, now we are good with that, and now it's time to, because we have changed our source code, we need to create new image. Okay, and then we need to push it to the Elastic Container Registry. So let's check first the images we have in my local machine, Docker image ls. So there are no images, so we can go ahead and create a Docker image of this app. Docker build -t for tag and app : previously we gave tag b1. This time I'm going to give a tag b2 and give the context. The context of build context is the current directory. Hit enter. Okay, it didn't take a long time to build image. Let me see the image. Docker image ls, and we can see our image is ready. Now we need to push this image into our repository in Elastic Container Registry service. For that, we need to retrieve the URI of the repository. Okay, so let me do that. I will be using command line to do that. AWS ECR describe repository, and we need to pass here repository name. The name of our repository is app, and optionally we can pass region as well, which is, for me, is Asia Pacific Southeast 2. Hit enter, and we have repository URI here. I will copy this and I will push. Now after we have this repository URI, we need to tag our image. Docker tag and repository URI. Hit enter. So nothing happened, that means it's good, and now we can push it. Docker push and repository URI. Hit enter. It's pushing. So it's been done. Now we can confirm this by visiting our repository. So this is the repository, and inside we can refresh it, and we can see it has come as a latest. It has a tag, latest tag, and we can see it's there. Okay, now what is the next thing? So now we have our image ready to be used by our containers. So now next step is to um, prepare a task definition. So task definition is nothing but defining the attributes and behavior of our container. For example, how much memory and storage, how much memory and CPU they can have, and uh, what image they can pull, and the name of the container and what port we should map. Those sort of thing we specify in a task definition. Okay, this video is going to be very long. If you think it's boring and you want to see the end result, you can do fast forwarding, maybe double or triple speed. Okay, so now what we do now, we go and create a task definition, right? So go to Elastic Container Service, and now we create a task definition. So what is task definition again? It's simply defining the character of our container, or behavior of our container. Okay, that's all. Okay, let's create a task definition. So task definition family name, we can give any unique name. I will give it app. And infrastructure requirements, since I'm going to use Fargate, which is a serverless environment, I will select Fargate type, and operating system architecture and network mode. So I tested my app on a Ubuntu Linux on 64-bit kernel. So I will select this one for me. And network mode is AWS VPC by default. And the task size. Task size is very important. So how much CPU and memory that we want to allocate for our container. So since it's a very lightweight application, I will give the very minimum amount of CPU and RAM. And this is very important here, the task role. Okay, we need to provide, it says a task IAM role allows container in the task to make API requests to AWS services. Okay, so what we want to do is just like, okay, I will show you that in action. For example, so when for our container to run, it needs to pull image from where? From Elastic Container Registry, just like this. Docker pull this. So this is Elastic Container Registry. That's the resources in AWS. And it need to pull. Right now, I am pulling it, right? And I am pulling it, and I can pull it. Why? Let me show you. If I pull it, yes, I have it. I pull it. How can I pull it? Because I have access key. I have permission to interact with AWS resources. I have already configured my AWS CLI with access key and the ID. That gives me unlimited access to any resources within my account. But for our container, when they need to pull this image from Elastic Container Registry, they don't have this access key and the ID. If we can do that. Like, we can provide our container access key and ID maybe, and use that to pull the image just like using this command. But that would be not a good idea, because we don't want it to have that access key for a long time. We just need to provide it when it needs, right? And it just needs only once when pulling the image. So that's where we create a IAM role for this container, so that this role gives it a temporary permission to pull image from Elastic Container Registry. That's why we need to create that IAM role. So IAM role is nothing but a temporary permission that an entity can assume. So I don't need to be involved there. It can automatically assume that role when it needs and interact with other services. Okay, that's what we are going to do. So we're going to create a IAM role for my containers to make API request to Elastic Container Registry service. So what I do is I will open a new console here. Before I create a role, I want to create a policy. I create a policy. What is policy? Policy is nothing but a set of permissions. For example, we can look at one of the policy here. And okay, let's create a policy. So what is policy? You will see policy is just a set of permissions. Permission, something that you can do on certain resources. So we can go very granular, and the best practice is the least privilege, so that we don't give full access, we give only what is necessary. Okay, so let's go ahead and create a policy. Policy for what? Policy that controls what can be done on Elastic Container Registry by our containers. So we need to create a policy here. So we need to choose a service. What is the service? This is Elastic Container Registry. So to pull image from Elastic Container Registry, we don't need to give all action permissible. No, that's too much open. So we can read through here, definitely not listing but reading. So we need to allow it to be able to batch check layer availability. Yes, I think so. Describe image, we don't need that. Describe repository, no. Get download URL for layers, I think that's necessary. Batch get image, that looks like I need to pull the image. Describe image, no. Describe repository creation, no. Batch get repository, no. Describe registry, no. Get authorization token, that will definitely need. Even when I did from my laptop to pull the image, I had to do this, remember? Let me see if I have that here. Yes, this is what I did, which is getting authorization token. So our container also need to do that, get authorization token, and I believe that's enough. So we are not doing any writing, we are just pulling image. So this 4 action will be enough. So what are you gonna do here? Specific. Do you want to be specific or on all resources? When I say specific, we can mention which repository, so we can do that. At the moment I will do any in this account and just create. Next, and I will give the name that is easy for me, is descriptive. So what I do is, the policy is allows containers to pull images from ECR, and put this here, and I can say policy. Yeah, I can go ahead and create this one. Okay, we have created a policy. Now policy is there, but we need to attach this policy to a role that our container or our task definition will assume. So let's go ahead and create a role. So create role, and okay, now this is where we need to select which entity will assume this role. So definitely the first one, AWS service like EC2, Lambda, or Elastic Container Services, that can take this role. And a use case, again select Elastic Container Service, and we can select the best one. So the best one is allows ECS tasks to call AWS service, in our case Elastic Container Registry, on our behalf. Yeah, that's fine. And next, and we need to select the policy. The policy is nothing but a set of permission. We can go here and customer manage, and the one we just created should be here. Allows containers to pull image from ECR. I will select that one. If you want to see inside, it has effect allow, so which means we can do something. And what we can do get down URL for layer, batch get image, batch check layer availability, and yeah, as well as on a resource all the repository within this account. And we have another permission here, which is also again allow. What we can do, get authorization token on all the repository, on everything. Okay, so we can go ahead with this and give it a name. I can say pull image from ECR role. And we can save it now. Create the role. Alrighty, so now we go back, and if we click here, we can see that role is being created. Pull image from ECR role. We can select that one, and we also have this task execution role. So I'm gonna select the default one, the one which is already created by AWS, ECS task execution role. The difference between these two roles is this task role is for container. This is for container. The container will assume this role. For example, if container needs to do something, let's say if the container needs to access S3, we need to give that permission explicitly to we need to create that role, or we need to attach that permission in this role. So, but this task execution role is not for a container, but for a container agent. There is container agent. It's like a sidecar along with the main container that needs certain permissions to make API request on the behalf of container. So I will select the default one. Now we are done with this infrastructure requirement. Now let's go to container. So name, what's the name of the container? We can give any name here. So I will give it app, and the repository URI, which is, we already know that what the repository URI is. So just AWS ECR describe repository, that's just repository name app, and what I get here is this is what I need. That's the repository URI. I will just copy this and paste here. That's the image URI. Okay, one thing I missed here is this. It doesn't say. Okay, this is not what we need. We need something different here. So I need to describe AWS ECR describe images. Repository name is app. What I need here is we have registry name and this full time. Okay, if I go to the Elastic Container Registry, container registry, this is the app, and this is the latest image, and this is the URI we need. So if I paste here, yeah, the only thing is it has latest attached. So what I can do is can come here and all good, but I just need to attach :latest. Yeah, so here I need to attach :latest. So every time we update, it makes sure that it pulls the latest image. Okay, so essential container, we can say yes. So private registry, which is we don't need because we are pulling it from within AWS, and now we need to map the ports. So container port, our container port is 8000. Sorry, 8000 protocol is TCP and app protocol is HTTP. That's fine. And read only root file system. Well, our container do not need to write anything on the root file system, but we can we don't need to do read only. I leave it as it is. Resource allocation limit. So this resource allocation limit and the task size, they are different. The resource allocation limit always should be less than task size, because the task size is the total resources container get. Okay, but we don't need to do it, it's very optional, and we don't have any environment variables at the moment, so I don't do anything here. And for logging, I just leave as it is. It's okay now. And with storage and anything, I don't need to do anything here at the moment. This is a simple demo. Create. Okay, our task definition is successfully created, which we can see from here. If I go here, and this is a version 8, because every time we create task definition, it doesn't, and when we deregister, it looks like it got deleted, but it doesn't get deleted. It's still there, because I already have created the task definition before. That's why it got the revision number 8. That's fine. Now let's go. We have our task definition ready. Okay, we can look more information here and go to app, and this is the information. So that's where the location of our image, that's where we are pulling image from. And yeah, this is it. Now let's go ahead and create cluster. So what is cluster? Cluster is just a bunch of computers where we will be deploying our containers, right? So, but here we do not create that resources individually. We are going to use Fargate. So Fargate is a serverless technology. We don't see what's happening under the hood, but we just get all the resources we need, infrastructures we need to run our containers. So I will just go ahead and create cluster. I will give it a simple name at the moment, app, and by default it also created namespace app and create. It takes a while to create a cluster. In the same time, I will go and heat up my tea. Okay. Alrighty, so cluster is created. So what do we do? So we already have task definition. So task definition just define how our container should behave. That's all. And now we have our cluster ready, which means a bunch of computers ready and there for us to deploy our containers. Now let's select that cluster, and we need to create a service. Okay, that service is the one that orchestrates the containers. So services which enable us to increase or decrease the number of containers. Service is what allows us to essentially orchestrate to meet the demand. So sometimes we might need to increase or decrease. That's all is achieved through this service. So let's go ahead and create this service. Our cluster is selected there, and I will select compute option launch type, and launch type Fargate, platform version latest, and the application type, this is service. We are selecting service because this is something we want to keep running like web application. So that's our choice. And task definition, we can select from here and app, and it automatically select the revision number. So because that's how we select it. Otherwise, if you select this, we need to manually provide it. Service name, I want to call it anything, I will call it name. That's the name of the service. And replicas, so how many tasks we want to run. So right now it's selected to 1, so we will be running 1 task of our task definition. If I select 2 tasks of our task definition. So I will select 2 at the moment, and okay, I will do nothing about service connect, service discovery, but I will need to change networking. Few things. Right now we need to put this container, we need to select the VPC, and we don't have VPC here, right? So this is good opportunity that I can show you how to create VPC from command line, and we can go from here. So we will create one at a time, the entity we need. Okay, we create VPC now. So I'm not using console, I will be using command line to create the VPC. Okay, let's create VPC. AWS EC2, it comes under EC2, create VPC. Yeah, if you hit tab, it gives all the options. Create VPC. VPC needs only 2 things. It's a CIDR block, which I always recommend using this one, and region. So region is Asia Pacific for me because I'm near from here, from Sydney, southeast 2. And we just hit enter, it creates that VPC. So one thing that I like to keep as a variable is VPC ID, but that I will be needing that one. So what I do is VPC ID equal to Control-Shift-B. So next time when I need VPC ID, I can simply refer to this variable VPC ID. Alrighty, and let me, okay, we got that VPC ID, amazing. Now choose subnets. We don't have any subnets, right? So there are no subnets. It's time to create a subnets. Okay, let's create a subnets, which is very simple. AWS EC2 create subnets. So for subnet, just like VPC, it needs 2 things. First, we need to provide the size of the subnet, I mean the IP addresses, range of IP addresses it can have. And second thing is we already have selected our region, but we need to select the availability zone where it can reside. So CIDR block should be 10.0.1.0/24, which comes under our VPC CIDR or subset of our VPC CIDR. And availability zone, I will select Asia Pacific southeast 2A. That's all, and I hit enter. It will, oh my goodness, I forgot something. VPC ID, that's what I need. Thank God that it doesn't go ahead and create subnet when I'm wrong. Yeah, okay, it created, so that's good. Let's create one more subnet. Okay, I will call that, this is in a we can create in the same availability zone or different. I will choose different one, and we need to change the CIDR to hit enter. Awesome, so we have subnet ready. So we can go ahead and select the subnet. Yeah, it already selected here. That's nice. But one thing, we have subnet ready, VPC ready, but the routing, we also need to create route because our container needs access to internet. So we need to create internet gateway and attach to the VPC and enable routing to the internet. Let's do that now. So let's create internet gateway. EC2 create internet gateway, and I want to give it a region. Region is Asia Pacific, of course, Southeast 2. When I hit enter, I get internet gateway ID here. So I need this. I will save this like this: internet gateway internet gateway ID equal to this. Awesome. Now we have internet gateway ID, but we need to attach it to our VPC, right? So this is another step to take. Attach internet gateway, and we need to say when we are attaching, we attach it to VPC. We need to tell the VPC ID, which is, again, this is very handy. Oh, my bad, I'm too early. I need to say internet gateway ID as well, and which is internet gateway and ID. It will work. Yeah, it did. Let me drink this coffee. Okay, now we have internet gateway. Okay, now what we need is we need to create a route. So we have internet gateway which is attached to VPC, but we need to attach this to the default route table. So let's get the default route table first. When we create VPC, it also create route table. Let's grab that route table. Actually, we need the route table ID. So AWS EC2 describe route tables. What I need is just, if I mention, what can I provide here? I can provide, of course, region and Asia Pacific Southeast 2. It gives us this route table. All I need is route table ID, this. So I select this and so I will say route table ID and save it. Now we have a route table ID. Now we need to create a route, right? Which is very simple actually. AWS EC2 create route, and we need to say when we create a route, so we are routing, so we want to route internet, so there should be destination CID block, which is 0.0.0.0/0, and there is a gateway. So what's the gateway ID is, of course we know that, internet gateway ID, and we need to point to the route table where we are working. So route table ID, which is route table ID. Good, it's good. So we have our route table now is aware of this internet gateway, and it has access to internet through this internet gateway. But remember, we all have created two subnets, but we haven't associated the subnets to this route table. So we need to get those subnets ID and attach it to this route table. So let's get the subnet ID. So AWS EC2 describe subnets. So we need to get the subnet ID. So I just want to write a query here. The query subnets. There could be so let's and dot subnet ID enter. So we have two subnet IDs. So let's associate our route table to this subnet ID. So AWS EC2 associate route table. Which route table? We need to say route table ID and provide that variable that holds route table ID. Route table ID dash and attach to subnet ID. So I will manually copy this, copying and pasting, hit enter, associated, and I will delete the subnet ID, subnet ID, and copy second subnet ID, copy and paste. All looks good. So we are good here. I believe we were done, so we can go ahead and check everything we have done so far. So what we can do is I will create a new window, VPC, and open in a new link and go to VPC and go to your VPC. See, we have our VPC here with that CIDR block size. Go to subnets. We have two subnets. We have route tables, and if I inspect this route tables, it has a route for internet wide and for VPC wide routing, and the subnets are attached. These two subnets are already attached, and we have our internet gateway here. This looks really good, so I will just cancel this one. So we are good with our network configuration. So we just created VPC, subnets, and create route, attach, and we associated the subnets to the route table. That's all good. I will leave public IP enabled so that we can access our application using the public IP. And at the moment I'm not using load balancing because my main aim is to show why we need load balancing. So because we have two containers and the user, when they need to access this application without load balancing, they need to actually type the IP address of each containers, which is not realistic. So we need to provide a common address that they can type, and that will take to the app, right? So load balancing is not now, but right now we will just deploy this. So now I'm happy with everything we have done so far. Okay, actually one thing is missing here, the default. This is the default security group, which actually we don't want. We want to create our own security group. So let's create our own security group. And I will be using command line to create the security group. Okay, let's do it. AWS, and it also come under EC2. Create a security group. Security group has a name, group name. I will call it my app, and give it a description. Description is allows traffic on port 8000. Why? Because our containers are listening on port 8000, and we have mapped that port 8000 to the host port 8000. So the host within the cluster is listening on port 8000, so we need to open that port for the traffic to reach the container, right? So that's it. And we need to mention the VPC ID here. Sorry, it doesn't take VPC ID. Okay, we just created. Okay, yeah, we need to specify VPC ID, which is this VPC ID. Yeah, now we have a group ID. This is something we need again. That's the group ID. So I will copy that and create a variable called group ID. And yeah, so now let's create, every time we create a security group, the outbound is always fully open. We don't need to worry about that. We just need to know about what can come in. That's the stateful firewall, so that anything that can come in, that same traffic can go back as well. So we don't need to worry about what can go, what can leave the system. Just create the inbound rule. Let's create the inbound rule for this group. EC2 authorized security group. If I say egress or ingress, this will be ingress for what can come in. So I need to mention the protocol. What protocol? Yes, this is a TCP, and I need to mention the port that we're opening, 8000, and from where. So this will provide the CID here from everywhere, 0.0.0.0/0. Hit enter. Oh, my bad, I again didn't do one thing. Group ID. Group ID is group ID, right? Okay, we just see, we can see here the this on a group ID, this we have from port 8000 to port 8000 and CID. All good, that looks good. So now we can go back and just update this, and we have our my app there, and we can go ahead and deploy our app from Elastic Container Service. That's amazing, isn't it? Okay, it won't take a long time. So what I do is I just hit refresh and I go to app and go to tasks. Right now it's in a pending state, and what I want to do is go to one of the tasks and go to log and check the logs. Since 5 minutes, and okay, something is happening here. See, it's running on this, it's running, app is ready. So now let me go back to tags. So there are two tags. To access this application, we need the public IP address, right? So what we do is we go inside, we go inside and we grab the public IP address. Okay, and here HTTP and paste, and on a port 8000. This says container IP is this. Now let's go and try another tax, second tax, and it has a different public IP address. they are different. HTTP and on a port 8000. Okay, you see, this is the private IP address of the host, which is running this container. This is 1.29 and this is 2.42. Looks like they are in different they are in different subnet, of course, different subnet. So because we have no control where we want to run it, right? But it looks like it distributed these containers in two availability zone we created. So they are obviously different subnet, and they're in a different subnet, means they're in a different availability zone. So this is how we can deploy an application in Elastic Container Service. But right now this is not good, because let's say we need to have two different public IP address, and we need two different public IP address to access this app, so which is not a realistic thing. So in the next video, what I do is I will show you guys how to configure application load balancer that will actually distribute traffic to all the healthy containers. So we need application load balancer. That's absolutely necessary. Why? Because these containers can die easily. They can die. Once they die, for example, sorry, I'm here and have this, they can die. Yes, when they die, their IP address it changes, so we really can't track the IP address. So we need to have a stable point of contact, or a stable point where users can access, and we need a way to track the IP address of new instances. So that is possible all by application load balancer. That's what we will do in the next video. See you in the next video. Thank you for watching this.